I thought it would be better to come into shot for this one because most of the people who watch my channel and those who know what I look like on the channel have not seen me how I look in the current situation that I am in as of recording this video. So here we go. And to those who know exactly what I look, yeah. I don't know how many people this is going to weirdden out, but I just want to point out that this isn't permanent. It's just temporary until the hair grows back, and the same can be said for the beard, which is my set. Forget how many attempts I've had in life growing a beard, but when this whole thing will be over, and it will be eventually, this will be coming off, and hopefully all my hair will come back. Anyway, on to the video. So roughly about 3.5 years ago, I made a video on how to build a UK Antweight fighting robot. Surprisingly, it ended up helping a lot of people, and it ended up becoming the most viewed video on this channel. One of the people who it did end up helping, I don't know how many of you know them, but it helped Will Owen from Team RC Robotics. He currently owns a machine called Capers, the heavyweight, previously owned by Tom Lloyd. And he said to me at an event in January 2018, they said that if it wouldn't have been for that video, that he wouldn't have been doing Antweights and probably wouldn't have been doing robot combat in general. So that kind of shocked me. So in this video I want to explain how to build a Beetleweight combat robot, but I'm going to be taking a very different approach to how I did it in the Antweight video. Because in the Antweight video I just basically gave a rundown of what goes inside an Antweight, like the components and the materials, and in general the whatever you call it goes into the making of an Antweight. But in that video I never really showed actually how you build the thing. So that's why I'm going to be taking that different approach to it. So in this video I'm going to show you how you can build a Beetleweight combat for just under £125. Now that price covers almost everything you see here, except for the HDPE, which is off screen. The price, however, doesn't cover stuff like the charger and maybe a couple of extras I mentioned earlier on in the video, but I will get to that eventually. So basically, if you're on a budget, I thought this would be a good video to help those who are looking into getting to Beetleweights, or those with little to no combat experience who are looking into getting to Beetleweights. Hopefully you will learn a lot from how I put together this thing. Yeah, it's just something a little bit simple, just some electronics on a base. It's not going to be showing you how to build, you know, probably the greatest Beetleweight that's ever been built. It's just going to be showing you how to build a basic one to get started, and just in general what goes into the making of a Beetleweight. Just to clarify, that £125 covers most of what you see here, including the HDP, which is off screen. However, it doesn't cover stuff like the charger, the tools that I've used, and maybe this little piece of wood here, but I don't know if I can put a price on that because I just found it in a scrap bin. I will explain later on in the video why it's resting on this, but here it is. This is how to build a Beetleweight for just under £125. Actually, I just realised while recording that segment, look, this button was undone, and that's probably not going to be a good look. Anyway, on to the tutorial. Okay, so first of all, starting off with the roundup of the components, I'm going to read off a list how much I paid for them so I don't get anything wrong. So all these components I will actually list in the description as well, so you know exactly where to buy them, and I will explain which options you may need to select on, a few of them, or a couple of them at least. So first of all, our radio gear. So if you don't have radio gear already, I would recommend the Flysky FS-i4, really good controller for beginners. Now, this costs just under £25. It does come with a receiver, but you do not want to use the one that comes with it. The reason for that is you cannot use it for combat robots because it doesn't have a failsafe on it. So instead, you need to use this receiver, which is the FS2a, which costs just under £4. And you will need to refer to the manual if it does include one, but there are some PDFs of it available on the internet somewhere that shows fail-safing and how to set it up on the receiver. So next up we have drive motors, which cost £3 each. Now, initially these were supposed to be 12 volt, so they are 12 volt, but they were supposed to be 1000 RPM, but instead the supplier sent me ones that were 1360 RPM, so they're still usable, but they just tend to be a lot faster. But for beginners building Beetleweights, the one I would recommend is 12 volts, 1000 RPM, and the listing on AliExpress will give you the option to select it. So in this packet here, we have our Drive ESC, which is a dual motor 5 amp one, and it costs £13. Now, really, people tend to use ones that are like 10 amp or a little bit higher than 5 amp, like it's 6.5 amp or whatever, blah, 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 blah. But I have actually tried these on these motors in particular, and I've had nothing go wrong with them, especially running them at 3S with the battery voltage. Speaking of which, so for our battery is a 11.1 3S 1000 milliamp Lipo battery. So this costs £10 on Hobby King. And very important, I do need to go with, definitely buy a Lipo bag if you are new to Lipos, and please always charge them in your Lipo bag. Do not charge them in flammable areas. Do not charge them in hot areas, or where it's like very, very hot at least. So also, make sure you use the exact right charger that is designed specifically to charge Lipo batteries, and refer to your charger settings and instructions. Because I once found out the hard way. I mean, I did use a Lipo bag, but the area where I was charging it just had to be redecorated. Next up, we have a fuse wire, which will be used in our removable link. So this reel, I think I paid... hang on, where's the listing? I forgot to put that on the list. Okay, so I found the listing, and this costed £8.39, so I'll just put that less than £9 or whatever. So 30 amp is the amperage you want for this, and the main reason the robots need to have a fuse in it is because to have something to stop the fuse. Oh god, I messed that one up. Okay, take two. So the main reason robots need to have a fuse in them is so that can burst if like the robot draws too much current. The fuse blows up before the Lipo does. Because if you know about what happens to Lipos when they do blow up, yeah, it's not pretty, and you're going to end up with we probably could end up with a entirely burnt out inside of a robot. So, for the removable links and also the battery connector, I will be using XT60s, so a pair of 5, which will come like this. So 5 pairs like this will cost, where's the listing, £6. So for building this Beetleweight, I will use 2 that are female and 1 that is male. Now, these 2 are actually ones I make myself, but I do have these, the motor mounts, for sale on my Etsy store. So these will cost just under £10. And these wheels, which, yet again, I have made myself, but these are not on the Etsy store yet. So, it's something I'm trialling out, but I could see a potentially new design for something like this. Will have the same hub and will fit on the same way, but could see moulded silicon tyres rather than Lego Technic tyres, which are what these are using. So because of the supplying costs, the machining costs, printing costs, and everything that I will have to need to work with, a pair of these, which could be new and improved, hopefully, will cost around £14.99, so let's make that £15. So now we've gone over the components, let's have a look at what to use for the main build of the robot, like armour and basing or whatever. Okay, well somehow I forgot to mention something during that particular take for this video, and that is these things right here. Now these are a couple of 100 ohm resistors, and I'll explain why I've got these later on in the video, but you can get these for £3 for a pack of 25. Something I do want to point out before I do get to these 2, the pricing that I'm mentioning does not include postage. The main reason for that being, and while I'm not mentioning it, is because for most of the items I'm using in this tutorial, they tend to come with free postage and packaging, in the UK at least. But maybe a couple or few items you may be charged for postage, but they won't necessarily be that expensive with the options available. Now these 2 are what people tend to use for building Beetleweight. So mainly this for the base plate. This is This is really 2mm polycarbonate, but I would recommend you use 3mm polycarbonate to be safe. It's also a good option for a base if depending on what you're using on your robot, it's a good lightweight option, and whatever you use for your weaponry, if you want to spare any weight or whatever, this would be kind of a good option. But really, just to be on the safe side, HDPE would be your best bets. Yeah, just basically use that one if you can't make room for weight or whatever. So HDPE is the stuff that most people in the UK tend to use for building fighting robots. Well, at least for beginning anyway. So this stuff is 10mm thick, which is the stuff I'd recommend you use. Somewhere between 8 to 12mm should be fine for Beetleweight builds. But yeah, so stuff like that, I should really mention the pricing actually. So, where is it? Okay, so the polycarbonate, a sheet of 250 by 250mm and 3mm thick will cost around £3.50. And a sheet of HDPE, 10mm thick, which is 25 by 500mm, will be around £14. So there we have our armour and our base materials. So let's just get onto the tools I'll be using to build this. Okay, so I'm not really going to go over the pricing for these tools because I'd imagine all households in the UK must have at least one or a few of these. So first of all, we'll be using a Draper soldering station, a Black & Decker 12V cordless drill, some wire cutters, which was included with a 3D printer I got, but they are available on eBay easily and can be found quite cheap. So Allen keys in various sizes and a whatchamacallit. To be honest, I generally don't know what this thing is called, but I'm sure there is a name for it, but I'm just going to refer to it as a holder. So there's the tools, and let's get on with how to do this thing and make the thing happen. Okay, so here we have our motors, our resistors, and our ESC, which I'll just take out of the packet so you can have a look at it. So there we have it. There's our drive ESC, so receiver connector ends, our battery connector. I will be taking this off because this is a JST connector. You can actually get Lipo batteries with JSTs. I don't know what they would be like, and I don't know what other people would say about using them in Beetleweights, but I think because most of my Lipo batteries above amp weights tend to use XT60s, I just tend to replace them anyway. You could buy a Lipo with a JST connector instead, but I don't know exactly what other people in the robotics community will say about that. If anyone does advise against it, then please put it in the comments below, but I am using an XT60 just in case. So, the polarity of our motors, I don't know how well the camera is going to be able to pick it up, but there is a red dot above there. That's positive, where the red wire solders on, and on this side where there's no red will be negative, which is where the black wire will go. Now the first thing we're going to do is we're going to take these resistors. Now the reason I'm going to be using these resistors is because the ESC in particular isn't great for braking, because what they tend to do is they cause the motors to roll forward, and what most ESCs tend to do is they stop the motor completely once your hand is taken off the transmitter or the radio stick or whatever's controlling it, whatever. So basically this ESC, what it tends to do is it does like a sort of continuous current and sort of slows the current down rather than stop it completely. So the reason why these resistors are going to be fitted onto the motor is to enable it for braking, because that's how things work. So we're going to bend the wires on the resistor like this, and where the holes are on the motor's polarity tabs, we're going to insert them in between here, place it in there gently, and what I'm going to do is just, my holder's not tightened up, so I'll just tighten that up, and what I'm going to do, hopefully it doesn't fall over. So yeah, so that's in. I don't know if I think my soldering iron is heated up fine, so what I'm just going to do is actually I should probably have that in the holder first rather than the motor. So we have some JSTs on the end here, so I'm just going to snip them off, and we can get rid of that because we don't need it. And really I should use a wire stripper for this kind of thing, but I just can't be bothered, and I just tend to work with what I got or whatever. So we're going to very gently have a little nip at the ends of the wire and then pull them off with our fingernails, and we have a couple of stripped ends on there. So what I'm going to do now is place the stripped ends in the holder, and oh Jesus, where's my solder? Back again. So that's one thing I forgot to mention in this video, because I'm an idiot. So soldering wire. So this stuff is lead-free flux core stuff, which is the stuff I prefer and I tend to use because it makes soldering very easy and hassle-free. So we have our soldering wire, and very carefully, to make sure if you are a child watching this, you get a grown-up to help you doing this, because the soldering iron is hot, hot, hot. So we're going to apply some solder to the stripped ends of the wire, like that. I think, yeah, that will be enough. So we're going to take that out of the holder and place our motor back in with the resistor. So what you want to do next is apply some solder to the motor tabs, but just be careful to make sure that the resistor doesn't slip. So apply it like that, and if you can hear the engine rumbling, that's my dad's turning up. So we've now got some solder applied to the motor polarity, so leave that to cool down for a bit. Actually, that's quite cool. So it tends to cool down quite quickly, but I'll just leave it for a little bit longer to be safe. So we're going to snip off the remaining wires from the resistors, and then once we've done that, we're going to solder the ESC's wires on. So because of the way I'll need to fit this inside a robot, you can shorten the wires as well if you want, but I need to have them this long because of what it's going in after the tutorial, so I'll be cannibalizing what I make of this and using it in something else. So we're going to solder the wire on here like that, if I can get it on. Yep, that's on, nice and tight. So with that one done, I'm going to do exactly the same process with this one on here. So I'll just do a time lapse of it because you've already seen me do it on that one and you don't need to see me do it again. Okay, so next we're going to move on to the battery connector. So the first thing we want to do is get rid of this JST connector, unless your Lipo does have a JST, unless you've been advised not to in the comments, like I said earlier. So just put that to one side because I actually need the that part of the, or they're either, I think they're male JST connectors, or I get the two mixed up sometimes. But anyway, so we got that cut off. So what I'm just going to do is strip the ends of the wires here. I'm just going to leave that for now. So put that to one side. Now we're going to look at the removable links. So every robot, regardless of weight category, apart from UK amp weights which use switches, robots, usually anything that's above amp weights, need to have a removable link. So it basically like works as like a sort of core fuse, if you like. So if you pull that out, the machine stops. If you plug it in, and it turns on the robot. So I'm going to be using the female for the link itself, and this part, the male, for the link insert. I'm just useless at describing things, but the other thing actually, most people tend to prefer using this for the actual link itself and this for the link insert, but usually I tend to do it the other way around, and the way I'm doing it, mainly because of the way the link insert fits into certain places, so it tends to make things a bit easier. So what we need to do is get the fuse wire, so Just gonna cut it to a certain length, so I think that should be long enough. And actually, where's my pliers? So anyway, here's the pliers. So what I'm just going to do is just bend it to shape. So like that. Just going to straighten that bit up a little bit, and then clip it on, and then bend it into shape like that. Actually, that end is a little bit too long, so what I'll do is I'll just snip that bit off so they're evenly matched. And that went flying, and I don't know where it's gone. So we're going to insert the fuse wire into the XT60 like so. Then I'm going to get the yeah, I've got the right camera setting. I thought I had it in time, that's then for a bit. So put the fuse to one side, and then going to solder the fuse wire in place on the removable link. So you're going to want to apply quite a bit at this stage to make sure it all gets nice in there. So okay, yeah, that's enough. The other thing I also tend to do, I'll have it shown in the holder just so it cools down a little bit. So what I tend to do is have both the male and female connected when doing these links, particularly because with the male connector, when you solder at a high temperature, it does tend to melt the overall casing of the XT60, and the connections that are inside, if I can put it, so these two bits inside there, they tend to sort of go out of shape because it tends to melt the plastic when you're soldering at a high temperature, so I tend to have the two plugged together when working with them. So we have our link, and what I'm just going to do is get a bit of, where's my cable tie? Okay, so we have a cable tie, and insert the cable tie into the link like that. To get your pinky, I'll probably hold it in like that. This is how I tend to do it. So get your pinky in it like that, and when it's roughly the right diameter, so snip the remains of the cable tie off, and there we have it. There we have our removable link. The other thing I would suggest as well is to get some heat shrink on the link itself, but I will also show an example of that I've done on previous links before that I use in featherweights. So just going to connect that back on because of something else I need to do. So what we're going to do next is, well, I say we, but it's just me doing it. So we're going to get our cables, the wire ends where the power goes into the ESC, and the other thing to point out is the terminals. So we have negative on that side, and positive on that side. Okay, so we got that in place, and I'm going to insert actually, just while I'm doing that, just going to apply some solder to the wire stripped ends. And there's one other thing I do need, and I'll just be right back to that. Okay, so I found some wire heat shrink. So basically just that simple, just going to cut off a little bits. Really I should be colour coordinating, so I should be using red heat shrink on that one and black on the other. But I'm just not going to bother doing it for this. Just keep it simple as I can, really. So thread your wire through the heat shrink like that, and do the same on that one. So then what I'm going to do is place the wire onto the connector, and then going to get the soldering iron and solder it into place. Yep, that's good. And then just thread the heat shrink on it like that. And then what you want to do is flip it round the other way and do the same thing on the negative terminal of the connector. So once that's soldered into place, if it does solder into place, which it has done, then bring the heat shrink onto the connector like that. So the other thing I will mention about heat shrink is you want to make sure that it is, when you're doing it for removable links, which I'll just unplug it because we've done for that one. So with removable links like this, you are definitely going to want to apply some heat shrink to protect yourself and maybe the arena floor, because it's made of metal, from sparks and electrical contact. So what I would recommend doing is, where's my calipers? I can't find my calipers. So I think a ruler would just be close enough. So what I tend to do is just measure the diameter, or the effective diameter at least, of the XT60, like that. And you will want heat shrink that's, let's make it around a 20mm diameter. So when you will apply it, when you will shrink it into place, yeah, it will do a good job at protecting lots of things from electrical contact. So what I'm going to do now is just plug it into this one. So we've got our battery connector. So what we're going to do is fit on the removable link. Now the way I'm going to do that is cut the wire like so, the positive wire like that, and then strip both of the ends off. We're going to stick those in the holder, and that one's come loose. So get some solder on those two. I don't know if you can hear my neighbours talking outside. I don't know if it's irritating or not. So there you have it. And what we need to do is cut 2 more bits of heat shrink. There you go. And then thread the wire there, and again so, like that. So we get our connector. So it doesn't really matter which way you do it round, because it's going to be flowing a positive current through the wire anyway, or through the connector as well. So put it into place like that. And then solder like that. I don't know if some people are probably going to worry about the smoke going into my face, but it's the lead-free stuff, so it's just non-toxic. So that's that one done with the heat shrink threaded and in place on that. Now we're going to do the same for this end of the wire. So push it a little bit so I can get it into place, and that's fallen off when it shouldn't have done. Now, can I get it into place? That is the question. Yes, I just about can. That will have to do. So, do the same process again. Solder it in like so, if I can. Like that. Yeah, I think that's enough. Okay, so there we have it. So we have our battery connector and we have our removable link. There's one other thing I do need to do first, and that's something I also forgot to talk about in this video, and that is a very important part of the robot, the power light. Something I forgot to go over during that segment was the power light. So a power light is something that is compulsory in all fighting robots above amp weight. I do know, as far as I'm aware, that in Australia, the power lights are compulsory in 150 gram amp weights, but they aren't in the UK. I don't know any other countries that rule applies to, but in the UK, power lights must be in Beetleweights and anything above that. They're not to be required in anything amp weights and anything below that. So the the reason robots need power lights is to indicate whether or not the robot is turned on or off. And this also applies to aesthetic lights. So I know there's been issues where aesthetic lights have had their own power source, or they've been running directly off a battery with no link attached. So any event organisers or anyone involved with the likes of Robot Wars, BattleBots or whatever, they can't tell if the robot is turned on or off. So any removable link, which I will get to in a bit, will have to deactivate all lights, even aesthetic lights, so they have the power light. And it's also against the rules not to have them in the competitive events. Yeah, so that's the power light. And this is one that I've already made out of a piece from a reel of strip lighting. I need to do a better job at explaining things. But so ones like these, you can buy packs of 4 of them for just under £4. And with that, on to the next bit. Okay, so here is that power light that I mentioned earlier on in the video. The way I'm going to do this is, so we can see the shrink wrap that's on the ESC, the transparent stuff. So what I'm just going to do is snip a bit of it with a pair of scissors. I should have got some better scissors. I didn't know how blunt these ones were going to be. So okay, so we've done that. So once I've done that, what I'm going to do is peel it back and expose the wiring terminals. Also take the link out because don't need it in. So the first thing I'm just going to do is push that aside for now. Put the wires of the light strip in the holder and solder the stripped ends. Like that, and that. So, with that, take that out of the holder and place the ESC in, and I'll explain exactly what I'm going to do so you can just get the better idea. So what I'm going to do is hold the soldered stripped end of the wire at the end of the ESC terminal, so be sure to match positive to negative. So I'm going to gently, I've got a blob of solder on the end of the iron, so I'm going to gently press on it, and also holding on to the actual, to both of them. So once that's in place, which it is, so that's soldered on there fine, I'm going to flip it round and do the other side. So I'm going to peel that a little bit forward so I don't end up melting it. And then holding on to both of the wires, well, let's just see if I can just do it without doing so. It's just, because it might show what happens if you don't. I'll just need to put a bit more solder on the end. So, yep, that happens. So that's why you need to be careful, because otherwise the battery terminal wiring will come loose. And I know that my fingers are probably a bit too close to the soldering, but let's try that one more time. Gently, gently, gently. Actually, I'll just apply a little bit more on, which sounded like something else, but oh well. I think that should do. So, just going to tug on that. Yeah, that's fine. So take that off the holder and peel back the casing on. I mean, what you could do is put some whole new heat shrink on, but I'm just going to leave it like that for now. But there we have it. So we've pretty much got the drive setup sorted, except for one thing. Okay, so when it comes to heat shrinking, most people would tend to use a hot air gun. Some people tend to hold a lighter or something that generates a flame underneath it. But one thing I just tend to use is a hairdryer. I mean, it works, and if it works, it ain't stupid. So here we go. I realised I made a mistake. So what I've done is I just had the... Oh, it's not that... Actually, hang on, have I done it? Okay, maybe not. So I just realised that that was just right down the end there, and I just let the hot air just get to it. So, anyway, back to business. Okay, so just tug on that. Okay, well that's not coming off. I know that's not probably the greatest of jobs, but if you use something like a hot air gun, or probably hold a lighter under it, and probably don't do that, because it might not be the most advisable thing to do with heat shrinking. But if you can use a hot air gun or a higher temperature hairdryer, I forget how old this one is, it's probably at least 30 years old or something, but the important thing is we have the heat shrinking. And actually, just while I've got it here, that heat shrinking I was talking about on the link, so something like this here, yeah, that's that. So now onto the transmitter and the receiver. Okay, so the receiver comes in two parts, well, three if you count the removable antenna. So what I'm going to do is get the pins on the receiver, like that there, so it fits on easily. So turn it upside down, put it on our holder, make sure that's on right, and then have the solder, and then I'll try and crop in on this, and I don't know how well it's going to pick it up, but just clean the solder first and solder it into place like so. So do, and onto the time lapse. And with that done, so it's warm but not incredibly hot. So going to bring back our electronics, and what I'm going to do is plug the one with the three cables, positive, negative, and the receiving end. So they should plug into the receiver like that. I'll actually bring it closer to the camera so you can see it better. There we go. So actually just turn off the transmitter, so don't need that. So what I'm just going to do is get the battery plugged in and get our removable link plugged in. Now, one thing I do need to do, so we know that a power light works, and we did get a beep from one of the motors on the drive, but one thing we need to do first is put the receiver into bind. So to do that, there is a little button on the receiver, so hold that down while turning the robot on. So the blue light on it is now flashing, so that's going into bind. So grab your transmitter and be sure to have your AA batteries fitted in before doing so, obviously. So bind key is this button here, so hold that down, give it about a few seconds, and once you've done that, take your thumb off the bind button, switch the transmitter off and back on again. So power light there, that works. Now to check the drive. No, that's fine. So just abuse test it first. Okay, so that seems to work. So take the link out, unplug the battery. So now on to the next part, fitting them onto the base. Now for the base part, we need our sheet of polycarbonate, or if you're using the HDP, then you'll need that. We've got our motor mounts, But I'll explain a bit more on the diameters of the holes when I do get to the drilling. And we have a couple of our Allen keys as well as the cordless drill. The first thing we need to do is take the sheet of polycarbonate. If you are using HDP, you won't have to do this. So we're just going to peel off. Actually, you'll probably get some good ASMR from this thing. Okay, I think that's probably my point or whatever. So, so that out of the way. So, probably going to end up saying that word a lot. Now, take our bolts out of the motor mounts. And also one other thing is you really don't want to lose these. So I'm just going to put these somewhere safe where they can't be lost. If I do lose them, then it's all because of my own stupidity. Because of completely forgetting where the hell I even put them. So, put these to one side. And get the bolts and the nuts off of our motor mounts. Right, so with those, so what I'm just going to do is carefully line up where I want to put them. So, roughly about here is where I want them to be. And what I'm just going to do is carefully, just to mind my fingers, is to drill a hole that's the same diameter as the motor mount, or where the bolts in there. So that will be 5mm thick diameter. However, if you do buy the ones that are on my store, they will be 4mm thick, and you will need to use a 4mm bit instead of a 5mm bit. So we'll just drill a little pilot hole, start off with, or a pilot marking. And then once I've done that, just need to find something to rest this on, actually. So best thing would be to do is to rest it on something that's strong enough and has a hole. Now, mark the drill bit onto where you have marked it earlier and start drilling, but very gently. So that's one hole drilled. And get the scrap bits in the scrap bin. And just for accuracy, what I tend to do is fit one side on. So we've got one side fitted, and place it very carefully onto our drilling area. Gently at first, and then push it to an angle, and then continue with the drilling. So, and then get the bolts, fit them in, and then fit the nut. Actually, there's one other thing, see? So using a pair of pliers. So just using it. So not really the best way, but I'm just using it. It's not really the best. So this is not the best way. Okay. So this is not the best way of doing it, but I'm just using the pliers to hold the nut in place. Really, I should be using a spanner for this, but just in case anyone at home watching this doesn't have a spanner, this alternative for me has worked before. So that's on tight, and now for the other one. So that's on nice and tightly. So what I'm just going to do is line up the second motor mount and then just repeat the same process. So there we have it. We have our two motor mounts fitted onto the base plate. Now, time to bring the electronics back. Now, the one thing you want to do before doing this is definitely make sure you get the correct direction control. So, what I mean by this is to make sure that the motors are in the right way. Otherwise, you'll just end up with a robot that just drives backwards. Well, it will drive forwards, but the controls will just be a bit awkward. So, hold them like this. And if they go clockwise rather than anti-clockwise, so yeah, that will mean it will go backwards, so I'm just going to flip them round. Okay, so that's the right way around. So unplug the battery and unplug our removable link, and we're going to bring back our 2.5mm bolts that are included with the motor mounts. So the best way I say to do this is just to insert them like so, and make sure that you have to spin them around for a little bit, and make sure that the threaded ends, or the threaded holes rather, I should really say, are perfectly lined up like that. So hold it in place. One bolt in position. Make sure that's on nice and tight. But not too tight, because you don't want to end up damaging the mount. Then we get our other bolt in the other side. Where's the camera seeing this? It's like, oh, there we go. So, yep, that's on. And do the same for the other side. That on tight. So we have both of our motors fitted. Now, there are a couple of extras I do want to go over before starting this next process that I haven't really talked about. So these two bits are just some double-sided tape and some Velcro dots, both of which are cheap and easy to buy. They're available at most stores, and they're easily available to get online on eBay or in many places. Can't remember exactly how much I paid for these, but if you put both of them together, I probably paid no more than £7. So for most of the components, we'll be using the double-sided tape, except for the Lipo battery, which will definitely have to be using the Velcro dots, because the Lipo cannot be charged inside the robot. They have to be charged in a Lipo bag. No exceptions and no excuses. And if you do end up with a Lipo fire, you'll probably end up with a lot of PTSD. So, starting off with mounting the ESC, to take right length, and where's my scissors? There they are. So we cut off a length there, place it underneath the ESC, and then peel back. Again, wherever you choose to mount it is really up to you, and whatever works best with your spacing in the robot. So I'm going to try mounting it here. So the strip lights, that comes with its own sticky back, so peel that off. Strip lights, I'm just going to put it wherever I can, so I'm going to just put it here. And you might want to press down hard on this just for reassurance, because on some strip lights the sticky back stuff doesn't tend to stick very well, but hopefully this one does. And finally, just a little bit for our receiver. So just that tiny little bit should be enough. So place that on the bottom. And let's just place the ESC here. So put that aside, bring in the Lipo battery, and the rougher bits, actually let's make it the smoother bits we'll put on the Lipo, so 2 should be enough. So 1, and then 2. So now we get a couple of the rougher bits, and stick them on like that. Let's try and get them as accurate as we can. So once we've done that, let's bring the base back and place the Lipo, press it for a little bit, take the Lipo off, and there you have it. So press them down just for a little bit, and there you go. So try and get them back on, and when connecting it, just be sure to tell apart from your battery connection from your link connection. What the hell am I even saying that for? So battery connector should be the positive and the negative wire, whereas the link holder should just both be positive. So that's pretty much all for the electronics for this silly little thing I've done for this tutorial. Now on to the final bit, which is our wheels. So wheels are pretty easy. Just actually, where's the... So what we need for this is our smaller Allen key from the set. So let's just loosen them up a little bit. So once we've done that, let's just do a little bit of tightening. That side and the other one. Let's take the shorter end in just to be safe, because it will be easier to tighten a lot better. Flip that along, and then if I can get it in, so just pull that off. That seems to be on tight for now. So we've got one wheel on, and now for the other side. And with that, we pretty much have our finished Beetleweight drive setup. So our Lipo is plugged in, and just going to power it on. So we have power, we have light. Okay, so take the link out, and yeah, that's pretty much all that needs to be done. And before I go over with a test drive to see how well it does actually perform, there's just a couple of things I do need to go through regarding the Lipo battery for anyone who is actually new to them. Now, the first thing I want to go over regarding Lipos is charging. So, the one thing you will have to have is one of these, a Lipo bag. because regardless of make, model, size, voltage or capacity or anything in between, you must charge your LiPos in a LiPo bag or any other form of fireproof container. No ifs, no buts. You can't just choose whether or not to charge them in a LiPo bag. Please, you have to charge them in a LiPo bag, because if you don't, then well, I think you'll just find out the hard way and just risk property damage or whatever. So I'm just going to demonstrate how I do this. So this is a larger LiPo bag that was LiPo. So this is a larger size of the Tenergy Nanotech, which is also what this one is. This was supposed to be using a featherweight, but I wasn't able to due to size complications. So I'm going to put that aside safely. Connect the Lipo to our charger. So open up our Lipo bag and be sure to tuck everything in nicely so that nothing escapes. So with that, we have our Lipo in, and I don't think the GoPro is going to be able to pick it up very well, so I'm going to have to record this part on my phone. So with regards to charger settings, on something like, actually there's one thing I haven't tested, it is a charger type. So this one I'm using is, I can't remember the company that made this, but this is a C2040 Duo. It's not really something I'd advise for beginners because it is a dual charger, but one thing I would recommend is a iMax B6, which I will link to in the description if you don't have a battery charger suited for LiPos. So the first thing we're going to do is, we have our Lipo charge setting, and so it's already on 3S, but we do have different voltage options as well. So we have 1S, 2S, 3S. So the battery that we're using for this Beetleweight is 3S, so it needs to be 11.4 volts, 11.1, sorry. So the battery we're using is 3S, so it needs to be set to that, 11.1, and 3.3 is on the previous battery, so we need to turn that down. So it's a 1000 milliamp pack, so we need to have this set at 1 amp. And I won't charge it because it doesn't need charging. But one thing you have to do as well is you have to monitor your battery charging at all times, or at least be in the same room it is while the battery is charging. Please don't leave the room while it's charging, and never leave the Lipo unattended. So that's pretty much all I have to say it is, and now on to the next essential for Lipo batteries. The other essential that's good to have is a capacity controller. So what this does is it tells you how much charge is in the Lipo and how much voltage is in each cell, anything in between then. So what we're just going to do is plug the balance connector into the appropriate terminal. So negative on starts from that end, and so it plugs in like that because it's a 3S. We'll do anything up to 7S. That's the only limit that this charge will go, but we can see that it has 70% charge. So it is set to LiPo, which is the battery type. So press cell, 3.9, 3.9, 3.9, 11.86 in total. So there we have it. So this is essential to have, and one thing I will also say is don't let this get below, or try not to at least, let this get below 30% charge. The reason you don't want to do that is because it does have a huge risk of causing one of the LiPos to be killed off completely, because you're going to completely drain it, there's going to be nothing left in it, and it's probably going to puff up, and you're just not going to have anything left of it. Yeah, so that's really all I have to say about the essentials, and now on to the test drive. Actually, before I go into the test drive, there's a couple of things I want to go over regarding fail-safing and cradles. So first of all, Beetleweights will need to be resting on a cradle when in the pits and when not in use. The main reason is, for example, if for any given reason it needs to be switched on or to be tested anywhere, this is to stop it from running off the table or whatever surface it is on in the pits. So there's no strict rules on how the cradle should be designed, but really for Beetleweights, something like a piece of wood like this should be enough to be used as a cradle, just as long as it's something that keeps the robot in perfect balance, and as long as the wheels aren't touching the ground. So now onto the fail-safing. So I'm going to try and plug the link in with one hand. If I can manage to... nope. Alright, so if I plug the link in, so we have power, turn the transmitter on. So here's how tech check works regards with fail-safing. So fall forward, turn the transmitter off. So if it continues to roll forward like that, then that would be a fail for the tech check. I just put it on the floor to just show what... There we go. Uh-oh. Okay, so yeah, I think you get the idea. So in order to stop something like that from happening, we need to turn to the receiver. So what you need to do is hold down the bind button, wait for it to flash, and once it's done that, that's the fail-safe reset. So if we go forwards, and then, hang on, forwards and turn the transmitter off. So there you have it. So it stopped completely, and that will mean you have passed the tech check regarding that area, as long as you passed all the other requirements for a tech check. So yeah, that's the fail-safing. So now onto the test drive. Okay, so time to test out this bad boy, and just a reminder that these motors are 1360 RPM rather than 1000 RPM, and these are running at 11.1 volts rather than 12. So if you do select the 1000 RPM option, they won't be as fast as crazy as this is probably going to go. But anyway, here we go. Going as gentle as I can be with the controls. And also, it's just basically very simple. So forwards, backwards, left, right. So let's just do a quick... Uh-oh. Definitely didn't tighten that wheel off. Okay, so I think you get the idea of how it actually works. So there you have it. And that was how to build a Beetleweight combat robot for just under £125. Yeah, so I hopefully that has been helpful to you if you've been wanting to get into Beetleweights. One thing I actually forgot to mention in the video was regarding the HDPE. One thing I would suggest is to hold it together with wood screws rather than regular bolts. The reason I say this is because the wood screws, when you've got the hole drilled at the right diameter, it tends to hold it in a lot better than bolts tend to in ways. I know a lot of people on the UK bot scene have built HDPE robots and have held them together with wood screws, and they've held up two spinners really fine. The other thing I did want to point out was that the ESC did get a little bit funny during the drive testing. That doesn't normally happen. I have tested this ESC on these types of motors before and it's driven perfectly fine. So it could be down to a case of maybe a faulty ESC. Yeah, I have actually got this working perfectly fine in other robots before. The other thing I do want to point out with this ESC is that I haven't tried it on four-wheel drive, like 4 motors per wheel and 2 motors per channel. I haven't even tried this on 6-wheel drive. I don't fancy trying it on 6-wheel drive, but I am thinking about trying it on 4-wheel drive and probably letting you know how that does get along and what happens from there. If it goes alright, then I will probably make a video about it, and if it doesn't, then I'll probably say no, do not use 4-wheel drive. But the ESC does run perfectly fine on 2-wheel drive, and as long as you've got those resistors on, you should have something pretty controllable. And that's going to be it for this video, so goodbye, good luck, and get building. Hopefully we'll see you in the arena someday.